Welcome to the University of Pittsburgh's Health and Explainable AI podcast. I'm your host, Jordan Gospore, a health and science reporter. Join me as we cover advancements being made in health informatics and explainable AI for students, researchers, and healthcare practitioners interested in applications of artificial intelligence and machine learning. This podcast is produced by the University of Pittsburgh's Health and Explainable AI Research Laboratory at the University of Pittsburgh School of Health and Rehabilitation Sciences Department of Health Information Management. Headed by Ahmad Tafti, Pitt's HexAI Lab cultivates extramural collaborations with academic institutions both nationally and internationally through its research, educational contributions, and this podcast series.
Hello and welcome back to the Pitt HexAI podcast. I'm Zoe Menezes, an undergrad student at the University of Pittsburgh. Today, I will be guest hosting a special interview with Shashank Manjunath, who is a PhD student in computer science at Northeastern University. Welcome, Shashank. To get us started, would you like to first introduce yourself and share for us what got you interested in computer science, medical imaging, and artificial intelligence?
Yeah, thanks so much for having me on. So I'm Shashank Manjunath. I'm a second-year PhD student in computer science here at Northeastern. I work with Dr. Aarti Sathyanarayana on biomedical signal processing problems. And yeah, so it's kind of been a long journey to get to this position. I actually studied my undergrad math and biomedical engineering, and kind of what drove that was a passion for math and specifically applied math. You know, when I was a kid, I loved doing like word problems, which everybody else hated, but I really liked them. And that kind of, when I started undergrad, I really knew I wanted to study math. And I took my first math class and I was like, this is cool, but when am I going to use it? The, horror of my professor, my poor math professor. And, I really tried to kind of keep that focus on the applied throughout my work. And, biomedical engineering, of course, you kind of get into very applied problems, specifically to like clinical and other biological applications. So yeah, once I graduated, I got a job working at a sort of R&D company, and I worked on some biomedical and a lot of non-biomedical stuff. And what that made me realize was that I really like the biomedical applications a lot more than the other stuff. So I decided to go back to school to study applying like math and computer science to these biomedical type problems.
How do you think all of the recent advancements in tech and AI have impacted your career so far?
Yeah, great. It's a really good question. So actually, when I first started doing research, I didn't even know what machine learning or AI was. This was like 2015, 2016. So right at the kind of the early stages of the machine learning AI boom that we've kind of seen in the last 10 years. And my first research project was on segmentation. So I was trying to segment these nerves from MRI images. And, of course, we had like this corpus of data that I could use. And I tried to build this pure signal processing algorithm, which, did some thresholding, did a couple other things, and tried to find where the nerve was. And, halfway through my summer, I was like, kind of, looking around on the internet, like, how do we do segmentation these days? And I found machine learning, and that's how I got started on machine learning. And I think that kind of over time, I've realized that this machine learning and artificial intelligence has kind of become sort of more fundamental skill set for people in the sort of like computer science and medicine area than maybe I'd previously understood. I think that people are a lot more expected to know neural networks and know, traditional machine learning, regression, linear and logistic, and random forest and those sorts of models a lot more than, maybe when I first started in research and, first started interacting with professors. So, yeah.
Yeah, that's really cool. Do you think that working with segmentation is easier today because of the advancements and everything? And what's your opinion on that?
Yeah, so I mean, there's definitely trade-offs. So I think that I used to work with this guy when my first job out of college. His name was Ross, and Ross had been doing computer vision for like 25 years. And one day I asked him actually the same question. I was like, "What do you think about like machine learning? Does it make it better or worse, or what are your opinions?" And he said, "Every day we work on something, and like apply a machine learning model, we're getting performance that I never dreamed of years ago." So I think that on one hand, machine learning and AI has really improved the performance of these algorithms. And I think that's, super important. Of course, you need algorithms that work at the baseline before we can start doing more things. But on the other hand, to the crux of this podcast, I think there's a loss of explainability there that definitely affects especially clinical trust in some of these algorithms. Because when you take like a more pure signal processing model, you can mathematically walk through it and say like these are the steps that we took to get to this segmentation. But with a machine learning model, that's maybe less clear, and I think that's an active area of research that people are really interested in.
Yeah, we were actually going to talk about explainability later on in the interview, but what's your take on explainability and what is its relevance to your work now?
Yeah, so I think explainability is really, really important, and it's really relevant to my work. So something I've tried to really keep into my work is being in touch with the clinician. So making sure that we work with the people who that hopefully one day, I mean, this obviously is very far away, but hopefully one day we'll actually work with the algorithms that myself or the whole group develops. And one of the things that we hear a lot is that they don't really know like where, if you build like a diagnostic algorithm, like where does the diagnosis come from, right? So if you went to a doctor and you said like, I have disease X, they would do a bunch of tests, they'd look at all that data, and then they would say, based on this, and this, I think that you do have or do not have disease X. So I think that explainability is key in that the people who work with the algorithm at the end really need to understand where these predictions come from. And specifically to my work, I'm not really an explainability expert, but one thing that I've tried to really integrate into my work is coming up with that data rather than the end conclusion. So trying to come up with specific measures that are fairly explainable and fairly understandable from the like signal processing machine learning approaches that can be presented to the clinician that do have some kind of predictive value that the clinician can then use in combination with all their other data to say that this is disease X or this is not disease X.
Working with clinicians, how would you explain explainability to them?
Yeah, so I think there's a few ways of thinking about this. So on one hand, I think doctors are very used to getting, as I mentioned before, like specific pieces of data that say like can potentially indicate a disease. So I think they're very comfortable with that. I think they're a lot less comfortable with the like direct diagnosis. So trying to come up with algorithms that explain a direct diagnosis, while it's definitely a really interesting research idea, I don't know if all the doctors that I've spoken with are directly comfortable with that yet. But as a researcher, I think it's an important scientific question, like can we explain a diagnosis that is made directly by a machine learning algorithm somehow? So there's two aspects to it. Like there's the building the things that clinicians will use, and on the other hand, there's like asking good scientific questions. And sometimes those are more parallel than intersecting. So, I mean, with my background in computer vision, I always think of this method GradCam. So with GradCam, what you can do is you can look back through a neural network and you can see like, if you're trying to classify cars, like what portion of the car did the network key on? It's like sort of an attention map in some sense. So that's one way to do explainability. But for the sort of clinical application, I tend to think of things like what particular marker in this signal indicated that maybe this is the particular diagnosis or particular piece of data that can potentially lead to a specific diagnosis.
Currently at Northeastern, you're researching signal processing and machine learning for time series health data with Dr. Aarti Sathyanarayana. Can you tell us about the lab and the types of questions that you're tackling?
Yeah, absolutely. So we tackle a couple sort of different types of questions. So my work is really focused on lower level signals. So I work really directly with time series signals and trying to diagnose kind of identify and diagnose specific diseases out of those kind of low level signals. We also have other PhD students who do some really, really interesting work on various types of data. So they've been working on studying depression from phone data and those sorts of questions as well, in addition to the very specific physical disease questions that I try to tackle.
What type of diseases are you working on?
Yeah, absolutely. So I'm really interested in EEG signal processing. And right now I'm working on, as part of kind of my direct research, I've been studying sleep apnea. And then kind of in collaboration with another group, I've been working on different epilepsy diagnostic techniques.
Can you talk more about your data sources and how you reduce noise?
Sure, yeah. For EEG signals, the particular data set that I've been working on is it's called the NCHSDB data bank, and I'll make sure I'll get this right. It's Nationwide Children's Hospital Sleep Data Bank. I think I got it. But yeah, so it's basically this huge data set of pediatric polysomnograms or pediatric sleep studies. And a polysomnogram contains typically quite a lot of data. So there's 6 to 10 hours of pretty high frequency time series signals. So you have things like EEG signals, of course, which is the thing that I focus on. Then usually have like oxygen saturation and EMG, electromyogram signals that measure kind of movement of the body during sleep. But yeah, so EEGs in general are pretty noisy kind of biomedical signals. If you take like a compare it to say oxygen saturation, there's a pretty well defined oxygen saturation that you can measure without too much invasion, like not fairly non-invasively. But with EEG signals, what you're trying to measure is like through several layers of a layer of bone, a layer of skin, potentially hair. So there's quite a lot of noise that comes into that. And the other point is that however many EEG electrodes you put on your head, it's never going to be like a one-to-one with the neuron that you're trying to measure. So you're in some sense getting like aggregate data that you need to parse through. So yeah, a lot of the work that I work on for EEG is trying to kind of identify the actual important signal through all of that noise that gets added in. And part of that for me right now is kind of trying to come up with creative methods or creative signal processing that can identify things that maybe haven't been identified before.
How closely do you work with doctors on this?
Yeah, so for this and for my epilepsy projects, we work pretty closely with doctors. The head of the lab that I collaborate with is an MD PhD, and he practices medicine. He's a neurologist. There are, I think, a few neurologists in that lab, and sometimes it really is helpful to load up a couple signals and send them over and say, "What do you think about this?" So yeah, I think working with doctors is really key because they're the experts on diagnosis, right? At the end of the day, as a computer scientist, what you're trying to do is augment the work of doctors in identifying disease.
Where do you see advances being made today in imaging and signal processing, and what are you excited about?
Yeah, so great question. I think a lot of the advances are going to be in kind of two areas. So first is new machine learning techniques, new AI techniques that are, as they get more powerful, the different information that we can extract from kind of signals and images. And secondly, on feature generation. So as we kind of get better at understanding different signals, how do we generate features that are really descriptive that doctors can use to make effective and earlier diagnoses of these diseases?
Before we close, we like to ask all of our guests to offer students a research project idea. So, what's something that you would like to see students working on? Is there a particular area of research you would like to see students working on?
Yeah, absolutely. And it's actually something that you guys have asked me about already on this podcast. I'd really like to understand kind of more comprehensively how doctors would like to work with explainability. I think that, as a researcher on the like very micro level, I work with one, two, three doctors, and they all have certain things that they want out of their computer science algorithms, out of the things that they work with, and different types of doctors want different things. So like radiologists would want one thing because they work with a specific type of data, but maybe a neurologist wants a different thing. So I'd really like to see a project that works to kind of understand doctors' different preferences of how they like to work with computer science algorithms and how they would like to understand the inner workings of those algorithms and the explainability of them.
Can you tell us more about your workflow and what types of tools that you use and how you think that what you're using now will change in the future?
Yeah, absolutely. Very interesting question for me. So I work on remote servers a lot. So I tend to work on kind of HPC, high performance computing systems. I work on Northeastern's computing system discovery almost constantly. And there's a lot of different, very nice visual interfaces. I choose to use just about the oldest one, Vim. So, we were talking about very progressive technology, and I'm using a text editor from like the 70s. So, but I've really been impressed with Google's like code suggestion search. So, if I want to be like, oh, what ports are open on my machine or something like that, I don't have to remember it anymore. I just go like, what ports are open, and Google will basically tell me. On the other hand, it's about 97% accurate. So you got to be careful about the 3% where it says that something will work when it doesn't. So yeah, I think that like currently I really like using Vim, and PyTorch is another thing that I use heavily. And I like all those tools, and I've always been really impressed with how well they work and how well they interact. But I think going into the future, probably some sort of like GitHub Copilot or ChatGPT style kind of augmenting tool that will help keep the little things out of your mind, right? Like there's always those little things that you don't remember how to do that you Google and go on Stack Overflow, and you're like, how do I do that? And I think that's really where these kind of more forward, more AI style code writing tools will really help.
Okay, one last question. Are there any large language models that you're currently following?
Yeah, so I generally follow like the kind of Chat GPT comings and goings as in the more pop tech world. But I've been really interested in these particular techniques for things like analyzing like medical records. I think that there's a lot of different. This isn't something that I regularly work on, and it's not something I've ever done more than a day or two of playing around with. But I think there's a lot of really rich information medical records that needs a human to be exploited right now. I think that's somewhere that ChatGPT can really help out. And I don't know if anybody's done a project on that yet already, but it could be something cool to work on as well.
Shashank, it's been a pleasure speaking with you today. We learned a lot. Thank you so much for joining us.
Thanks everyone for tuning in and for following the show. The Health and Explainable AI podcast is produced by the University of Pittsburgh's Health and Explainable AI Research Laboratory at University of Pittsburgh School of Health and Rehabilitation Sciences Department of Health Information Management. I'm Jordan Gaspore. Thanks for listening.